The difference between ordinary and extraordinary is just that little bit of extra. So come, let's put in some extra work. Welcome to part 2 of our paper 1 revision. Guys, I'm so excited to present to you this beautiful masterpiece where we're going to be delving in the heavy tariff questions, as I've told you in the first part of the revision. I just want to say welcome to all the new subscribers. I'm so happy to have you in our community. And guys, I can see that some of you are revising the first part that I've uploaded. I know that sometimes it might be so tiring, but guess what? We're going to push. Push means push until something happens. So we are going to make sure that we keep revising. So guys, once you have watched part 1 and you've watched this part 2, I'm confident that you are prepared to tackle those questions. Now, part 1 would have been where you have secured your grade. So on the first part of a GCSE paper, you should have already secured your grade, a pass grade. But on the back of the paper is where now we're trying to get some of those high 4 and 5 markers where we're trying to see how high can I put my grade. So when you get into your exam, you're going to relax and you're going to execute what we've done together. I'm so happy to be a part of your journey, guys. And guess what? I'm ready to begin. So guess what? Let's go. We're going to start our first question. We begin with linear graphs. Here is the graph of a straight line. Stop. First thing I heard from the question was a straight line. So before I go any further, I'm writing down the general equation for a straight line. So it's y equal mx plus c. M is my gradient. Let me just write that down. C is my y-intercept. And that is where my straight line will cross over the y-axis. Now I continue to read. Clear logical thought. I'm asked to work out the equation of the line that I see on the graph. Now I have already put my formula down. So I know that if I need the equation of this straight line, I need my gradient and also my y-intercept. So I'm going to focus first of all on my gradient, which is m. So I know from a graph, the gradient of a line is y over x. Some people say rise over run. So I have to make a perfect right angle triangle on this graph. When I say perfect, I mean you cannot have like a 3/4 square, a half square. It has to be dead on accurate. So I'm going to choose this point here and also this point here. That is dead onto the line to make my triangle. Now it doesn't matter the size of your triangle once you've got perfect squares. Now, key point here is to make sure that you look at what we are going up by, the scale on your graph. If the scale is going up by 1, we can then count the squares for y and x. If we are not going up by 1, we should count the unit instead. So when I observe on my x-axis, I am going by 1s, so that's okay. My y is also going up by 1, 2, 3 as well. So that means for this particular question, I can count the squares. So for the y, 1, 2, 3, 4, and for the x, 1, 2. So gradient here, notice before I write my coordinates down, I'm going to pay attention to the orientation of the line. This means the direction that my line is going. That is going to influence if my gradient is positive or negative. So let's go. So if I'm sloping from right to left, I will have a positive gradient. That's very important. But if the graph was sloping from left to right, it would be a negative gradient. Remember that. So this is going to be positive then. So I'm going to substitute y for 4 and x for 2. So my gradient of this line is 2. Check that off. I'm finished with part A. Nice and easy, clear, logical thought. Now I go to part B. So let's just put A here. We're on to B. So work out, underline key fact, again, going to the gym, working out. The coordinates of the y-intercept, important language there, of a line that is parallel, another key point, to the line in part A. Now, if two lines are parallel, their gradients are equal. If two lines are parallel, they have the same gradient. So it also should pass through the point 2, 2. So first line of thought here is that I know at least one thing about this line that's parallel to the line I just found the gradient of. I also know its gradient. So the gradient of this line would also be equal to 2, just like the one before. So now I need to find the y-intercept of that line. But I was given a specific coordinate that is also on that line. So let's put what we have so far. So I know for this line, y is equal to 2x plus something. Don't know the value of c yet, but I can find it because I know a common point on the line is 2, 2. So let's write that common point here, 2, 2. I know that x is 2 and also y. So to find the constant c, which is my y-intercept, I just need to substitute the values of x and y into the equation. So y is 2, so that's 2 equal to 2, bracket. X is also 2, so I'm substituting x for 2 plus c. You should see your gaps closing now, so let's go. 2 times by 2 is 4, 4 plus c. I now need to subtract 4 from both sides. Be careful, 2 take away 4. We are doing a small take away a large. Clearly I'm thinking my answer is going to be negative, so this is minus 2 is equal to c. So the equation of the other line is going to be y equal to 2x and minus 2. Be careful. I was asked not for the y-intercept, but the coordinates of the y-intercept. Now, whenever we have a y-intercept, x is always 0. So therefore, the coordinate will be 0 for x and the y coordinate will be minus 2. So my answer, on exam papers, most times we find people go all the way to finding what the value of c is, but didn't pay attention to the fact that you were not asked to find the y-intercept, but the coordinate of the y-intercept. That's very important. Absolutely brilliant. So moving along, we are now going to do another linear graph questions integrating ratios now. So we're told here, we're given the ratio AB is 1 and BC is 2. So AB to BC is 1 to 2. We're given this straight line with the coordinates of A, 0, 17, coordinates of C, 9, 2, and we're asked to find the coordinates of B. So key information here is my ratios. Now I know the distance from A to C is going to be 1 plus 2, which is 3 parts in my ratio. That's the total from A to C. But I notice from A to B is just 1 part out of the 3. So A to B then is going to be a third of the total distance of A to C. So the first thing I need to do is to work out how far is A from C. We can do that by subtracting the corresponding x and y coordinates. So let's label x1, y1, x2, y2. So for the x coordinates, the total distance AC is equal to, for the x coordinates, I'm going to do 9 take away 0. And for the y coordinates, I'm just going to put them in separate brackets first and then put them back together, will be 2 take away 17. So for the x coordinates, I will get 9. For the y coordinates, I will get minus 15. Pay attention, it's a small take away a large. So that's a total distance from A to C. Remember, AB is 1/3 of that. So I need to find the distance from A to B. In terms of coordinates, we have to divide this by 3 since it is 1/3. So we need to do 9 divided by 3 and also minus 15 divided by 3 to find out what is the distance from A to B. So 9 divided by 3 is 3. And minus 15 divided by 3 is minus 5. Now, this is not your answer. It's how far A is from B. So to get the coordinates of B now, I'm going to need to take into consideration that from 0, I'm adding 3. So here, I've got 0, 17. I need to add 3 to 0 for the x coordinate. So 0 add 3. For the y coordinate is going to be 17 minus 5. 17 minus 5. So 0 plus 3 is 3 and 17 minus 5 is 12. Therefore, the coordinates of B is 3, 12. Absolutely brilliant. This question comes up a lot. Now, may come up in a different form in terms of you will get a quarter, ratio 1 to 4 or whatever, but it's the principles that works. So watch it again if you need to, but make sure you can do these styles of questions. Well done. Okay, so we move to our next question. Another question on linear graphs. So we're told we've got a coordinate minus 310 is a point on the line L. So highlight. We've got 4, 0, and 6, 10 are points on M. So this words is just describing the diagram. When you read your words, you make a connection with your diagram straight away. So L and M are parallel keywords. What do I hear? Same gradient. Important there. We're asked to work out the equation of line L. Give your answer in the form y equal mx plus c. Beautiful. So let's look at what we've got. We have 2 coordinates on the line M, but we only have 1 pair on the line L. So what we need to do, because I know the gradients are going to be the same, I can find the gradient of the line M, and then I will also know the gradient of the line I was asked to find. So when I'm finding the gradient of a line from 2 points, I have to use a different formula. It's still y over x, but it's in terms of coordinate. So the gradient from a line is y2 take away y1 over x2 take away x1. So let's label up these coordinates. I've got 4, 0, and I've got 6, 10. So the first pairs will be our 1s, x1, y1. Second pair, x2, y2. So let's substitute that in the formula. Always write your formula and substitute directly into the formula to avoid common errors. So let's go. y2 is 10. We're taking away y1, which is 0, divided by x2, which is 6. And we're taking away x1, which is 4. We get 10. And then 6 take away 4 is 2. So the gradient then is 5. Well done. So we found the gradient of the line M. We know that the gradient of the line M will also be the same. And remember, we need to find the equation in the form y equal mx plus c. So already I have my gradient. So I'm going to write that down. Y equal to 5x plus c, because I don't know what c is yet. However, I know a point on the line L to be minus 310. So I'm going to use that point, substitute it into what we've got now. Then I will have the constant at the end, which is my c. So let's go. I'm going to do minus 3 and 10. So let's label. This is my x coordinate. That's y. So I'm going to substitute y for 10 here equal to 5 times by minus 3 plus c. So 10 is equal to minus 3 times 5 is minus 15. Add c. Now I need to reverse this, so that's plus 15 on both sides. I will get 25 is equal to, this cancels out here, leaving me with C. So now I know my y-intercept. So my answer is then y equal to, my gradient was 5, so that's 5x, and my y-intercept is 25. So the equation of the line L then is 5x add 25. Well done. Okay, moving along. We have another question, but this time we're talking about perpendicular lines. Okay, so straight line LM has equation y equal to 4x minus 7. Straight line ST has equation y equal 9 minus x divided by 4. Are the lines LM and ST perpendicular? Tick a box, give a reason for your answer. Key point here is perpendicular. So we spoke about parallel lines having the same gradient. So when two lines are perpendicular, their gradient is the negative reciprocal of each other. So let's write that down. Negative reciprocal. So negative reciprocal of each other. What does that mean? It means that if one gradient, for example, is 2, the other gradient perpendicular is going to be negative 1/2. Remember, the number 2 can be written as 2 over 1. But we need to flip this over. That's how we get a half, but it must be negative. Now, critical point here is that when you multiply two perpendicular gradients, the answer must always be negative 1. So let's go. 2 times by negative 1/2 is equal to, so this will cancel, 2 into itself goes once, minus 1 times 1 is minus 1. So yes, negative 1/2 and positive 2 for gradients are perpendicular. So this is what we're looking to identify in this question. So line LM, so M, the gradient of line MLM is equal to, coefficient of x here is 4. So what am I looking for? Is the gradient of ST negative 1/4? Now, the best thing to do here is to rearrange the formula or write it properly where I can see it clearly in the form y equal mx plus c. So I've got y equal to 9 minus x quarters. Please note that the quarter, the 4, shares 4, so I could write it like this. Putting my gradient first, I will get minus, so minus x is my gradient, but minus 1x. So I'm just going to put that invisible 1 that's before the negative sign. Let's rewrite it as minus 1/4 x. Plus the 9 is also out of 1/4, out of 4. So now this is rearranged. I can see clearly one gradient is 1/4, minus 1/4, and the other is positive 4. So let's go. 4 times negative 1/4. Let's see if that's equal to minus 1. So negative 1 times 4, negative 4, divided by positive 4 is minus 1. So therefore, we are confident they are perpendicular. So we will say yes. Give a reason for your answer. We can simply say negative 4 times that 1/4 minus 1/4 equal minus 1. Therefore, or we could just write in words, the gradients are the negative reciprocal of each other. Key point here, we must make sure we rearrange our line in the form y equal mx plus c, where we can clearly see our gradient. So minus x indicates minus 1x, which is going to be out of 4, so minus 1/4 x. Absolutely brilliant. That's a key point. A lot of these questions come up to ask you, prove that these two lines are perpendicular. We're looking for their gradient. That's what we want from you. Show us the gradient of the first, show us the gradient of the second, multiply them together, show us you get minus 1. Yes, they are perpendicular. Absolutely fantastic. So now we go to another question here for 3 marks. The line AB has equation 5y, so let me just rewrite that, 5y equal to 2 minus 3x, and CD has equation 3y equal to 5x add 1. Okay, is AB perpendicular to DC? And I've done this question, another one of it, because this is a flag, a red flag for us. We know students get these ones wrong. So remember, I must check that my two lines are rearranged in the form y equal mx plus c. And then if they are perpendicular, then their gradients will be the negative reciprocal of each other. So let's rearrange the first one. So AB, we have 5y equal to 2 minus 3x. Rearrange, we need 5. We need y to be the subject of the formula. So we are going to be dividing all of the equation by 5. So this cancels out, leaving me with y equal to, I'm going to rearrange this and put my x first so I see my gradient clearly. So this is minus 3/5 x for this part here. My constant is 2/5. So this one already been rearranged. Let's rearrange this one. So 3y is equal to 5x plus 1, making y the subject, divide by 3, divide by 3, divide by 3. So y then is equal to 5/3 x plus 1/3. So let's get the first gradient. So gradient 1 is minus 3/5. Gradient 2 is 5/3. We observe they are the negative reciprocal of each other, minus 3/5. So we invert that, we get 5/3 positive. Beautiful. We could even go as a further to do 3/5, negative 3/5 times 5/3. We can see here 3 into itself goes once, into this one goes minus 1, 5 into itself once, 5 into itself once. We get negative 1 times 1, negative 1, dividing by 1, still minus 1. So then you must answer the question intelligently for the final mark. You were asked specifically, is AB perpendicular? Now, if you stop here and you haven't made a conclusion, you have lost the final mark. So you now need to say, yes, they are perpendicular. And this is the symbol for perpendicular. Let me show you that. Yes, answer the question that was asked. Absolutely fantastic. Okay, so now we are going to move on to another question. But before we do that, let me give you some tips and some traps to avoid. So what we've noticed is that people forget the negative reciprocal rule. The most common mistake is forgetting that rule, negative reciprocal. And please don't confuse that with reciprocal. If I give you the number 1/5 and I ask you for the reciprocal, that's just 5 or 5/1. That's not the same as a negative reciprocal as it relates to perpendicular lines. Key point there. Now the rule, if the gradient is m, the perpendicular gradient is, flip it, the reciprocal. Change the sign. So if you got 2, it's going to be minus 1/2. That's the reciprocal. Okay? Mistakes students make. Students only flip or change the sign, but do not do both. You got to do both, guys. You got to do both. Another error is that errors with the fractions. So when gradients are fractions, the mistakes increase. That's what we see based on research and looking at trends over marking. So 3/4 is going to be minus 4/3. So common errors, writing minus 3/4, only changing the sign and not flipping, or flipping and writing no signs. That's not you. We are flipping and we are changing signs. Fantastic. So say it in your head. Flip and change signs. Flip and change sign. I could hear that loud and clear coming back to me. Beautiful. So we will do this other question here, and then we are moving a little bit further. Okay, so points P, Q, and R is 8, 22, form a triangle. Now, PQ is a horizontal line with P on the y-axis. So we relate to that. P is located dead onto the y-axis. Horizontal line here for PQ. The gradient of PR, which is this line here, is 2. Work out the coordinates of Q. So 5 marks, guys. So now it's time for application of skills. So first of all, I know the gradient of PR, which is 2. Let's underline that. I want the coordinates of Q. So first thing I notice, I know no coordinate at all for Q. So that means the PR will have to help me to get at least one coordinate from there. It's a reason we do not just give you knowledge or give you sentences loosely. If we tell you the gradient of PR is 2, we expect you to use it. So therefore, what I'm going to do in order to find the coordinate of P, I am going to be finding the equation of PR. So we know the equation will be y equal mx add c. So I already was told that the gradient of PR is 2. So let's substitute that. So y equal to, the gradient is 2, x plus c. Now I need the y-intercept. Now I have one coordinate pair that I know the coordinate 8, 22. I can substitute that in this equation to find C. And if I have found C, which is this coordinate here for P, I will also have known the Y coordinate for Q. So let's substitute 8, 22, which is X and Y. So 22 for Y is equal to 2 times by 8 plus C. So 22 is equal to 2 times 8 is 16 plus C. So 22, take away 16, remember, taking away 16 from both sides, equal to C. So 22 take away 16 is 6. So that means C is 6. So that tells me the coordinate of the y-intercept. So let's complete the equation. Y equal 2x plus 6. So that means the y-intercept here is 6. So that's 0, 6. Beautiful. Which means that I also know the y-coordinate of Q. So already I know one part to the answer. Because this is a straight line, that means the y-coordinate of Q has to also be 6. Now I need to find what is the x-coordinate. But I notice this is a right angle, which means that PR and PQ are perpendicular. So that means I can use that value to work out the equation of RQ or QR. So perpendicular, if the gradient of the first one is 2, the negative reciprocal of that would be negative a half. Negative a half x plus c. So now I need to find out the equation of this line here. And if I find the equation, which I can because I at least know a point on the line, so I can use 822 to get the y-intercept for the line QR. So let's substitute 822 into this. So I got negative a half x is equal to, y equal, so 22 is equal to negative a half times by x, which is 8, plus c. So multiplying by a half is the same as dividing by 2. So essentially this is minus 8 divided by 2, which is minus 4 plus c equal to 22. So now I just need to add 4 to both sides. So 26 is equal to c. So the equation of this line, P, so let's write it down. So QR, equation of QR is y equal to negative a half. Remember, its gradient is reciprocal, x, plus the y-intercept is 26. So now I know that, and I know the y-coordinate here. I'm going to substitute the y-coordinate of Q into this to find the x coordinate. Let's go. So y equal to, so 6 is equal to negative a half x plus 26. Step 1, subtract 26 from both sides. I will get, so subtract 26 from both sides. 6 minus 26 is equal to minus 20. And that's equal to negative a half x. So we are multiplying by negative a half here. On the other side, we need to divide by negative a half. So I'm just going to rewrite it here for clarity. So I'm going to put it as minus 0.5 x. Dividing by a half, remember, is the same as multiplying by 2. So dividing by a half on both sides. So therefore, x then is equal to minus 20 times by minus 5 or 0.5, so multiplying them, or we could just cancel out the points and then do 20 times by 2 is equal to 40. So we knew the y coordinate was 6, so the coordinate of Q, so coordinates of Q, make sure you write it out. Coordinates of Q is equal to 40 for x and 6 for y. Lots of information there, guys, but the 5 markers is the difference between a grade 5 or a grade 7 to 9. And what we're doing, 7 up. So you may have to play this over again, but make sure that you get it. Absolutely fantastic. So now we move on to a very famous topic on a paper 1. It is the equation of the tangent of a circle. Beautiful. So let's read the question. So P is the coordinate 2, 4 that we can put in straight away. So 2, 4, let's put that here. 2, 4, coordinate P is a point on a circle with center O. Again, key information here. So before I even start reading the question, I am putting in things in place that will help me to break my question down with some clear, logical thoughts. So I know if this is the center, then the coordinate is 0, 0. Good, I've set myself up. Now I'm going to read the question. We're asked to work out the equation of the tangent to the circle at P. Give your answer in the form y equal mx plus c. So I want the equation of this tangent, which is the straight line onto which P sits. Okay, very important point for you to remember at least that part of your circle, because you could also be asked to give different names for different parts of the circle. So that straight line that touches the circumference of the circle is your tangent. So first of all, I recognize I have a point on my tangent. So let's write the equation down. I know it should be in the form y equal mx plus c. Okay, I don't know the gradient of the tangent and I don't know the y-intercept of the tangent either. However, I can put in my radius here. So if I put my radius, this is supposed to be going all the way to P, guys. So this now creates a right angle. Remember, we've just talked about perpendicular gradients. So I can find the gradient of my radius since I know 2 points here. So let's find the gradient of the radius. So gradient of radius is equal to, we have 2 points, so y2 take away y1 over x2 take away x1. But guys, when the circle has a center of O, which is 0, 0, then if we do, let me show you, and then I'll show you the shortcut to that once the center is 0, 0. So y, let's label them x. So I'm going to put 2, 4 here and 0, 0. So if I do y2 take away y1 and x2 take away x1, doesn't matter which pair you call the x1s and the y1. So for example, it's easier for me to call this one the 2s and this one the 1. So 1, 1. So x1, y1, x2, y2. So I'm going to do y2, which is 4, take away 0, divided by x2, which is 2, take away 0. So 4 take away 0 is still 4, 2 take away 0 is still 2, and that's equal to 2. So the gradient of the radius is 2. Now, you could see that because I know I'm going to always subtract 0 when the center is 0, 0, I could have just done x over y, which is 4 divided by 2. Gets me straight to the answer of 2. Okay, so if you get a circle, your center is 0, 0, and you're finding the gradient of the radius, you could just do y divided by x. Okay, on the exam condition, you want to make sure you have a lot of time to check back over your work after you finish. So we're trying to work smarter, not harder. Okay, so now I've got a key information here, because I know that the radius here and the tangent will have a perpendicular gradient because they meet at a right angle. So if the gradient of the radius is a half, then the gradient of the tangent is going to be negative a half, the negative reciprocal. So gradient of the tangent, I'm going to call that M2, is equal to negative 1/2. Perpendicular gradients. So I can now find the y-intercept since I know a point, which is P, on the tangent as well. So let's set up y equal negative a half x plus c. I can find my c by substituting x and y. So this is x and this is y. So 4 is equal to negative a half multiplied by the x is 2. And that's plus c. So negative a half times by 2. So you can see here, if I do 2 into itself goes once, then I will do negative 1 times 1. So this is 4 equal to negative 1 plus c. By adding 1 to both sides, I get that, 1 here, 5 is equal to c. So now I know the y-intercept, then the equation of the tangent is y equal to, the gradient was negative a half, and we know we have to put x. I don't like the way that looked, guys. Let me just fix it. So let's go again. Want to make sure you see it clearly. So it is y equal to negative 1/2 x. Don't forget your x, and the plus 5 is our constant, or the y-intercept. And just like that. So guys, you can see one of the key principles here, mathematics is highly linked. We call it a spiral curriculum. So you know how to find the equation of a line. You know that the gradient of two perpendicular lines are the negative reciprocal of each other. You know how to substitute points in an equation. Then those are all the bits you're putting together. No more will you leave the equation of any tangent at all. So guys, I have done a complete lesson on equation of circles, and more complex ones, you can find that here. Make sure that you take a look at that lesson as well. That was requested by another student, so feel free to put in your requests as well on things you want me to do going forward as well. So just like that, we have done that 4 marker. Now we go to some number topics where we are asked here to work out 15 squared divided by bracket 1/5 times by the square root of 25. And the first thing that should come to your mind is that good friend of ours called BIDMAS. So let's write it down, BIDMAS. We know when we have multiple operations, we always work our brackets first, indices or powers if there's any, division, multiplication, addition, subtraction. So let's go for working our bracket out first. So we can put 15 squared here. We expect you to know all your square numbers from 1 to 20. 20 times 20 is 400. 15 times 15 is 225. That's what we're after here. So we expect you. But guys, if you forget, use your column method, 15 times 15, and work it out. Okay? Divided by, let's work our bracket out. So 1/5 times by the square root of 25 is 5. And then if we simplify the bracket, so let's just put this back, 225 divided by 5 into itself goes once, 5 into itself goes 1. All of this simplifies to 1. Essentially, I'm just doing 225 divided by 1, which is still 225. Just like that, I'm finished with that question. over to the other one. 6 plus 2 times by what's in my bracket, 5 squared minus 3 squared, and we're dividing all of that by 4. Again, same principle applied. Do I have brackets? Yes. But within the bracket, I still need to apply BIDMAS. So let's go. I'm just going to rewrite 6 plus 2 here. Not ready for those. So let's work this out. 5 squared is 25. Take away 3 squared is 9. Divided by 4. Notice I am just working on the bracket, so I'm putting back everything. Next I go for, I cannot add these together. That's not what's happening here. Let's simplify our bracket. So we're multiplying now by 25, take away 9. That is 16. Put back our division by 4. So now we have done our indices. We now need to do, so what we have to do here, whenever we have multiplication and division in the same question, we can do them simultaneously. So now I'm going to choose to go for my multiplication first. So 6 plus, we've got 16 times by 2 is 32 divided by 4. So I'm now going to go for my division now. So this is 6, add 32 divided by 4 is 8. And we have 6 plus 8, that is 14. And that's our final answer. Now, let me justify why we can do multiplication and division. We do not only have BIDMAS, we also have BIMDAS. The order really doesn't matter when we have them side by side. The rule says when they're side by side, you work from left to right. So in this case, multiplication and division was side by side. So we're working from left to right. That is the rule straight away. Now, what if you had done the division first? It would be 16 divided by 4, which is 2. 2 times 2 would have given you 4. See that? So you got to be careful with what you're doing here. So, 16 times by 4 into 16 goes 4. 4 2 is 8. So you would still have gotten the same answer there. So remember, multiplication and division stand side by side. We can work from left to right. Okay, we go to inequalities on the number line. Which inequality is represented by this solution? So I always say, when you're working on inequalities, guys, and you're getting an option, you need to do the question first and then look for the answer. So I must remind myself that an unshaded circle means the number is not included in the answer, not included. And if it's not included, I will have either a less than or greater than sign with no shading, no line under it. Just to remind you of that. When I have a solid circle, it means that the value is included, and it will be either of these two with the lines under it. Now, before I go further, let me invite you to watch this lesson here on inequalities on a number line. Very, very important for you to do that. So now let's go. We know X is going to be in the middle. So let's look. We put our two boundaries. My boundaries are 2 and 6. So now I need to follow the criteria here. So going to the right here, notice there's no shading here, so it's going to be either one of these two. By the way, the signs always go in the same direction for both sides of the equation, or the inequality rather. So going from 2 to the right, I am increasing. So X then is greater than 2, no line under it. Now going from 6 to the other way, X is going to be less than 6, so turns away, but it's shaded. So a line has to be under that. So I'm now searching for, so we know this cannot be an option. We know this cannot be an option because we shouldn't have a line under here. We know this cannot be the option because both of them are not with lines under. So the answer has to be this. So let's check. X is greater than 2, but less than or equal to 6. So you see how I work through my 1 markers? Because I know 1 mark is the difference in changing my grade. Very important, even though it's 1 mark. Talk yourself through the question. So now we go to, We are asked to circle the set of integer. Remember, by the way, when we talk about integers, we're talking about whole numbers, whether positive or negative or zero. So if you look at a number line, you're looking at integers. Notice you never see fractions or decimals on the number line. Even though they exist, we are only focused on the whole numbers. So we're asked to circle the set of integer values that satisfy this inequality. So I'm going to rewrite it. 2n and then minus 4 and then 2. So within the lesson I've just pointed to, you will get some examples like this as well. But remember, in the middle, we must always have either x or n. Can't be 2n. No. So what we've got to do first of all is to divide everything by 2 so that we get n on its own in the middle. So minus 4 divided by 2 is minus 2. Then we will have n in the middle now since we are dividing by 2. And then we will have 1 here. So again, look at the value here. The sign here tells me that minus 2 is a part of the solution. So minus 2 is a part of the solution. Less than 1, 1 is not a part of the solution. So we need to go minus 2, minus 1, 0. 1 is not included because there is no line under it. So the answer then has to be this one. Talk yourself through it. Clear, logical thoughts, guys. And that's how marks are won or lost. But on this side, we do winning. Thumbs up there. Let's go. So now we are going to look at inequalities from the graph this time. Okay. So here we are asked to, on this grid, show the region represented by x greater than, remember, open mouths always turn to the greater number. The shark loved the bigger fish. So x is greater than. Now, similarly to what we've done on the number line, equivalent here we use either dashed lines or solid line. So when there is no line under, this one will be using a dashed line. Be careful. This one will also be using a dashed line. And because there is a line under this one, for that we have to use a solid line. Okay, so therefore what we need to be doing, we are going to be drawing the graph of, so we say x is greater than 2. So we have to make x exactly equal to 2. And then after we've plotted them all, we will look where is greater than that line, where is less than that line, and so on. So remember, x is dead on equal to 2. Go to the x-axis, find 2. That will be a vertical line, but remember, it has to be a dashed line. So label it now for your examiner. X is dead on equal to 2. So the region that will be greater than this is on the right-hand side. So every number on the right is greater. So somewhere over this side here, we know is going to be where we're shading, but we've got to do them all first. So let's tick this off. We stuck to the dashed line. Here now we need to do y is greater than 1. So we need to make y exactly equal to 1. So that's the y-axis. We go to 1. Again, another dashed line. Label for your examiner. Y is exactly equal to 1 here. So if y is greater than 1, it is going to be above the green line, but still somewhere over here. Now I need to draw this one, which is the most complex one, but I'm going to make it really simple for you because we are going to make it exactly equal to 12. But we're going to use the cover-up method for this. Now, using the cover-up method means that I'm going to make x equal to 0 first. So you're going to write x equals 0. Therefore, if x equals 0, we will have 2 times 0 plus 3y equal 12. So we're going to have 2 times 0 is still 0, so 3y equal 12. So dividing by 3, I get that y is equal to 4. Remember, we made x equal to 0. So a coordinate we could plot is 0 to 4. So let's plot that. 0 to 4 is dead on. 0 to 4 is dead on here. So x first, 0 to 4. So now we're going to cover the y1 to get another coordinate to plot. So covering y. So now that you know that when you cover 1, you actually makes the value 0. So when y is equal to 0, all of this 3y is now 0. We will then be left with 2x equal 12. Dividing by 2, we get that x is 6. So therefore, another coordinate we can plot, 6 for x, 0 for y. We go here, 6 for x, 0 for y. We only need 2 points to draw that line. So now we're going to put that in, make a straight line. Now we're going to shade our region. Beautiful. One of the most beautiful thing about these sessions is that you can always replay the video. Isn't that sweet? Beautiful. I haven't yet said to you, like this video right now and get this algorithm boosting. I'm sure you're benefiting and you want others to as well. So let's go ahead, hit that thumbs up. And by the way, do you know you can hype the video now and send it even further in the algorithm? If you're on your cell phone, you just need to look where the like button is. Maybe you need to scroll over. You will see hype and press that hype and send this video up in the algorithm. Beautiful. So now that we've plotted our graph, the only thing we need to do now is to say 2x plus 3y. This is where it's exactly equal to 12. So now let's get where we should shade. We know it should be, for this one, x is greater than 2. So we know it's going to be over this side of the line to the right. We know it's supposed to be greater than greater than 1. So it's going to be above the green line. And it should be less than this line, less than the purple. So the region is here. You can just put a big R there. This question could have also asked you, therefore, find the area of the shaded region. Some people may have just put their shading in like this instead of writing R. A question could then further say, find the area of the shaded region. The shaded region is a triangle. So let's just do it and extend the question. Base times height divided by 2 is the area of the triangle. So the base is 1, 2, 2.5 squares across. And the height of the triangle is 1. I'm just going to say this is 1.5 because the question wasn't really designed to do this. You will then do 1.5 times by 2.5 divided by 2. So I'm not going to take it further because I want to make sure you get the relevant other questions that's left. So that's what you would have done. Sometimes when you shade your region, they could be trapezium. You will apply that formula, which you will get on the formula sheet anyway. Beautiful there. So we are moving. Non-calculator paper, exact trig values come into focus. So guys, here we are. So in this question, we're asked to work out the area of this triangle. Underline key thing in the question. Give yourself the thought. So area of this triangle. So we look at this triangle. It's a right angled triangle. We need to write the formula down first of all. So the area of a triangle is equal to the base times the height divided by 2. I now need to ask myself some question. Do I have all the information I need? I go and check, do I know the base? No, but I do know the height. So I've got the height, I don't know the base. I need to work out the base. But I can see here, so let's just call the base B. This is a right angle triangle. So therefore, the first thing that comes to my mind when I know two sides of a triangle, I am using Pythagoras Theorem. So Pythagoras Theorem says a squared plus b squared is equal to c squared. But careful information here, we have the longest side. So we only add if we're finding the longest side, and we subtract if we are finding the shorter side. So therefore, b squared is going to be equal to longest side, which is c squared, take away a squared. So let's go, substitution. B squared then will be equal to c squared, longest side 17. So 17 squared, don't forget your square, equal to 8 squared. Again, guys, we expect that you know your square numbers. So we are doing 17 squared, which is 289, and we are subtracting 8 times 8, which is 64. Do not rely on your mental skills. Write it out. 8289, take away 64. 9 take away 4 is 5. 8 take away 6 is 2. 0 take away 2 is 2. So 225. B squared is equal to 225. So B is the square root of 225, which you should know is 15. Trial and error if you don't. Okay, but if more than likely it ends with 5, so clearly 15 must be the go. So let's label our base equal to 15. Now let's substitute that in. So area is equal to the base, which is 15, times by the height, which is 8, divided by 2. Easy way to do this, divide 8 by 2 first. So 2 into itself goes once, 2 into 8 goes 4. Now I'm doing 15 times by 4. Easy way to think about this. 2 sets of 15 is 30, and I need 4 sets, so that must be 60. If you can't think about it like that, set it up. 15 times by 2, and then add that onto itself. So 60, don't forget your unit, centimeters squared. Beautiful. So the next question, we are given that cos 30 multiplied by cos 45 is root A over B. Work out the values of the integers. It should be A and B. However, there is a typo from the past paper. So I need to use my exact trigonometric values because this is a non-calculator paper. So let me help you here. If it is that you don't know your trig ratios from your mind, try to learn at least these 2 triangles and then use the triangles to get the answers. Don't try to study them all. So we have, if we want to get our 30s, whether cos 30, tan 30, sin 30, we can use the triangle with 60 and 30. So 30, 60. So we start with a right angle triangle. We got 60 here, 30 here. We got 1, 2, root 3. So just think about counting 1 in an anti-clockwise way, 1, 2, but instead of 3, that one is root 3. That takes care of our 60s and our 30s for all 3 ratios, sine, cos, and tan. If I want to get my 45, which I'm going to be using my 45 here, so I need to draw the isosceles triangle where I've got 45, 45, 1, 1 for the shortest sides, and root 2 for the hypotenuse. Know these 2 triangles is to know all your trig ratios at the same time. So when you get into an exam before the panic and whatever comes on, draw out these triangles and have them there. Once they say begin, you write this out and you're ready to go. Okay, so now we are doing cos 30 multiplied by root 45. So we are going to the triangle to get what cos 30 is. Remember, cos is equal to adjacent over hypotenuse, so ka. And guys, if you need more practice on your trig ratios, you need to watch this video here. I've done a lot of work on that, which is going to be also good for your paper 2 and 3 as well. However, if you need more on exact trig values, you need to watch this one, which is the year 10 paper 1 walkthrough. That has almost everything that you need, but this one, this current walkthrough, will give you additional practice as well. So that's what you can do as well. So let's go. We know cos is adjacent over hypotenuse, so I need to go to 30 and I need to see adjacent is root 3. So let's write what cos 30 is first. Cos 30 is equal to, let me just erase that bit. Need to write cos 30. So cos 30 is equal to, the adjacent side is root 3 over the hypotenuse, which is 2. Let's go now to write what cos 45 is. So I need to use the triangle with the 45s. It doesn't matter which one of the 45s you use, the values will still be the same. So I'm going to go here. I need the adjacent, which is 1, over the hypotenuse, which is root 2. So now I need to multiply them. So cos 30 is root 3 over 2 times by cos 45, which is 1 over root 2. So let's multiply them now. Root 3 times 1 is root 3, and root 2 times by root 2 times by 2 is 2 root 2. So now we need to put it in the form A over B. So if I'm going to do that, just write that. Notice I don't put 2 equal sign in my sum. The root here is 3. And I need to find out which square number did this 2 come from. That came from 4. So the square root of 4 is 2. That means if I times 4 times by the 2 inside, then I will get 8. So therefore, it will be 3 over 8. So let's do that again. This came from something that was simplified. Okay, so to get 2 root 2, that was root 8 being simplified, because root 8 is equal to root 4 times by root 2. So when we simplify this root 4, we got 2 and we got root 2 here. So if I want to work backwards, I need to multiply this 2 by 2 and then times it by the 2 inside. So 2 times 2 is 4, and 4 times the 2 inside gets us 8. So therefore, A is equal to 3 and B is equal to 8. But we have to get it back in that form, okay? Beautiful. Make sure you watch that again if you need to, and then you will get that value. So let's keep going on a little bit more trig values now. So we're asked here to work out the height of this triangle and give you an answer in surd form. Again, we will always be doing surds when it's an uncalculated paper. So let's go. We need to look. We always start at the angle. So I'm going to stand on 60. I only label the part of the triangle that I want to find and the part that I already know. Don't label the blank side at all. That will confuse you as to what ratio you're using. So I am using opposite, label that opposite, and hypotenuse. I want the ratio with OH, so that's sine. So I'm going to need to use my exact trig values again. But let's write out the formula. So sine of an angle, so sine theta is the opposite over the hypotenuse. The angle here is 60, so sine 60 is equal to the opposite is h, and the hypotenuse is 8. So because I've just drawn the triangles there for you, I've just popped them back here. Know these triangles, you'd have also written them down on your paper. Okay, so therefore, we are going to replace sine 60 with the exact value. So we need the triangle with 60. So we go to 60, and sine is the opposite, which is root 3, over the hypotenuse, which is 2. So root 3 over 2 is replaced with sine 60. That's equal to h over 8. Now that I've replaced sine 60 with its exact value, opposite over hypotenuse, root 3 over 2, I'm cross multiplying now. So 2 times h is 2h, and that's equal to 8 times by root 3 is equal to 8 root 3. And so dividing by 2, I get 2 cancels out here. So h is equal to 8 divided by 2 is 4, and we got root 3. So the exact value is 4 root 3. If you need some other examples, or you need to find out the basic operation with multiplying and dividing surds, then you need to watch this video here. See how many goodies I have for you guys? Brilliant. So we are moving on. So the next question up is another question using exact trig values, and I've already pre-put back the triangles there. We're told that ABC and ACD are 2 right-angled triangles. We are asked to show that CD is equal to 2. I love these questions. 4 marks, but we already know the answer we're working towards. Therefore, if we get it wrong, we know and we don't leave it. We go back and try to improve it. So I want to find that CD is equal to 2. So let's put a letter here. So CD, this is what we want to prove. That's 2. If you notice here, we only have the angle, but we don't know any other side. So we need to use this triangle here, the triangle ABC. We've got to use that first to get the side AC. So I'm going to call AC X. I need to work that out. And if I know this side, I will now be able to work out CD. Okay, so let's go. We're working with this triangle. I suggest that to avoid confusion, you sketch the triangle again, take it off. So this is 45 here, and I've got root 6 here, and I am trying to find X. That will give my focus just to this triangle here. When I get my answer, I'll replace it with X on the other shape. So let's go. Set up, we need to see what ratio we are using. So if we notice, I don't have the opposite. I don't label that at all. I have the adjacent, and the hypotenuse is what I want to find. So A and H means ka, so cos, we're using cos. So let's go for it. So cos 45 is equal to, that's the angle here, the adjacent is root 6, and then that is being over the hypotenuse, which is X. So now I need to go to my 45 triangle and find out what is cos 45. Remember, adjacent over hypotenuse. I go to this 45, the adjacent side is 1 over the hypotenuse is root 2. So cos 45 is 1 over root 2. That then is equal to root 6 over X. So let's cross multiply. 1 times X is X, and root 2 times root 6 is root 12. Okay, now since we're going to use root 12 again, we may just keep it like that and put X equal to root 12 there. Okay, we don't have to simplify it yet. So now I'm going for my other triangle, which I can now use to find Y. So let's draw that one out. Right angle triangle again. I've got 30, and I know that this side now is root 12, and I want to find Y. Okay, so again, from 30, Y is the opposite, and let me just put that in bracket, and we have the adjacent side, which is root 12. So I'm using OA, which is TOA, so tan. So tan 30 is equal to the opposite, which is Y, over the adjacent, which is root 12. So now I need to find out what is tan 30. So I go to my 30 degrees. I know that tan is the opposite, which is 1 over the adjacent, which is root 3. And that's equal to Y over root 12. So now we're going to cross multiply. So cross multiplying, I get Y times root 3 is Y root 3. And that's equal to 1 times root 12, which is root 12. Now I need to divide both sides by root 3. So let's go, team, let's go. So that cancels out, leaving me with Y. Root 12 divided by root 3 is root 4. And the square root of 4 is 2. So therefore, Y will then be equal to 2. And remember, we were to show that the answer is 2. So we then conclude to say Y equal to, therefore, this is a symbol for therefore, you could write it out, CD is equal to 2 centimeters. 4 marks. Clear, logical thoughts. Guys, I am absolutely proud of you for continuing your revision. Remember a little bit, the difference between the extraordinary and the ordinary is that little bit of extra, which you're putting in right now. So proud of you. Okay, we go on. We are going to do one final question now, which is 2 marks this time. We need our trig values as well, but I'm just teaching you how to reason. So here is a triangle ABC. We got hypotenuse, and we've got 60 degrees, and we've got a short side, 17. Is ABC a right angle? Now, tick one box and show you're working to support your answer. Now, As it relates to right angle triangles, we have to think about our trig ratios. So let's set up here and see which ratio would we use with these sides. So we got opposite and hypotenuse. So we're doing sine 60. So to answer this question, if we need to find what is the original value of sine 60 and see if when we equate the sides by substitute them in, we get that value for sine 60. If we do, it's a right angle triangle. So let's find out what is sine 60. So opposite, hypotenuse, so go back to our 60. So sine 60, opposite is root 3 over hypotenuse root 2. So that means when I substitute the sides in here, so let's write what it's sine 60 in terms of the sides we're given and see if that's root 3 over 2. So from this diagram here on the triangle, sine 60 would be equal to the opposite, which is 17, over the hypotenuse, which is 34. If we simplify this, we get 17 into itself once, into 34 goes 2. So the answer is a half from the triangle and not the original value of sine, which should have been root 3 over 2. So we will then conclude, no, it's not a right angle triangle. We will then say sine 60 is equal to root 3 over 2. A half is not equal to root 3 over 2. Therefore, that's how we make that conclusion. Beautiful. Now, if this was a right angle triangle test in Pythagoras Theorem, if they ask you if it is right angled, then what you would have done is make a squared plus b squared equal to c squared. If when you add the square of a and b, you get the same thing as the square of c, then it's right angled. If not, it's not a right angle. Application there. Beautiful. So we keep moving. Now we are going to another triangle, but now it's Pythagoras Theorem application. So let's see. All dimensions are in centimeters, not drawn accurately. But guys, we have all just algebraic expression. We got x, we got 7x, we got 10y. We're asked to use Pythagoras Theorem. Key point here, a very kind question as well. It shows you the direction you should take. We're asked to work out the exact value of x and y. Exact value, again, I'm thinking something along the lines of Surds. Okay, so here we go. We are going to set up our formula. We know that a squared plus b squared should be equal to c squared. Examiner's tip, remember, the hypotenuse is the longest side. Common mistakes we find, student mix up the sides. So the two short sides, x squared, put that in bracket, plus 7x squared, important to put it in bracket, equal to 10y squared. Why is it important? We are not just squaring 7, we're squaring 7 and also x. So x squared is still x squared. 7x squared, if you have to write it out, let's write it here. 7x times 7x, 7 times 7 is 49. X times x is x squared. Guys, you see how I write my things clearly? This is what you got to do. That's equal to 10y squared. So again, if I have to do 10y times 10y, 10 times 10 is 100. Y times y is y squared. Absolutely fantastic. So now I notice I've got two terms in x squared can be added together. So 1x squared plus 49x squared is 50x squared. That's equal to 100y squared. Remember, I want y over x. So my aim is to get y and x as a fraction of each other. So the first thing I'm going to do, I'm going to be collecting my like terms. So if you notice here, I am multiplying 50 by x squared. I'm going to be putting 50 on this side to be with 100, but it has to be a division on that side because I'm multiplying here. I'm going to put y squared over that side, but it's being multiplied here. It's going to be a division on the other side. So if I move 50 to the right, I'm going to have x squared here. If I moved multiplication by y squared, I'm going to have division by y squared there. I'm left with 100. I was multiplying by 50, so I'm now dividing by 50. Absolutely beautiful. So now I wasn't asked to get x squared divided by y squared. I was asked for x and y, so I have to square root. So I'm going to square root both sides. Let's look. So square root removes a square, so now I'd have just x over y. So if we divide this, 100 divided by 50 is 2. So our exact value of x over 5 is root 2. That's an exact value. Absolutely brilliant, guys. Beautiful. Okay, so we are going to be moving on. So we're going to simplifying some surds now, not about using the exact values. This is straight surds now. And I've referred you already to a video that you can use to see addition, subtraction, multiplication, and so on of surds. So we're asked to work out 7 over root 2, and that is being multiplied by root 3 over root 10. Okay, so we're going to multiply. We get 7 times root 3 is 7 root 3. And root 2 times root 10 is root 20. So we are asked to give our answer in the form x root 15 over y. So what we've got to do here, guys, we got to rationalize. So to rationalize, let me just rewrite this here. So times by r over root 20. To rationalize means that I should not have a surd in my denominator. So to get rid of this surd, I need to multiply it by itself and also the numerator by root 20. When you multiply two identical surds together, you will get the number by itself. So that's equal to, so we got 7 root 3 times root 20. You can only times the surds together. So that's 7 root 60 over, remember, root 20 times root 20 is just 20. But remember, we need it in the form root 15. So I'm going to have to write root 60 in another form. So let's go. So root 60 can be written as, just break it down along the side. So we need a square number that goes into 60. But remember, one of our numbers has to be 15. So what square number times by 15 makes 60? That's 4. So root 60 can be written as root 4 times by root 15. Okay? So if that's true, then we will then have, let's put this back together now. So 7 times by root 4 is 2. So square root of 4 is 2, and then root 15 over the 20 we had. Just to make sure you haven't lost your train of thought. Then root 4 is 2. So instead of root 60, I'm writing 2 root 15. Let me just put an interjection here. Root 4 is 2. And 2 times that is, so that's how we got 7 now. Instead of root 60, we are multiplying it by 2 root 15. So let's simplify, and that's our final answer. 7 times 2 is 14. So we get 14 root 15 over 20. Okay, so we can also further simplify this by dividing 4 and 20. So we could say, or we could half them. So 14 divided by 2 is 7. And we will have root 15 over 20 divided by 2 is 10. So that could also be our answer. But it didn't say we had to do it in its simplest form. We only needed to have a root 15 here, where x and y are integers. Okay, beautiful, guys. So can we just tell our examiner what's x and y as well? But on the answer line, we will put 7 root 15 over 10. You can therefore write somewhere on your space that x is equal to, the number before the surd is 7, and y is equal to 10 here. So this is supposed to be 15. Beautiful. So that's our answer. Make sure you are specific. Your answer line is where you put 7 root 15 over 10. Somewhere in your working space, you let your examiner know how intelligent you are, that I know that x is 7 and y is 10. Absolutely brilliant. Okay, Moving on now to another Surds question, and the reason I'm going through all this is this paper one, heavily Surds, heavily Surds, heavily Surds. Okay, so we're going to go on, but have you yet shared this with a friend who may not have met this channel yet? Guys, let's not be selfish. Let's share the channel out. And remember, you can hype the video so other people you don't even know will benefit from this as well. Beautiful. So in this question, we're asked to simplify root 80 plus root 2 and 2 ninths. Give your answer in the form a root 5 divided by b, where a and b are integers for 3 marks. So the first thing we need to do here, we are going to simplify root 80. So remember, when we are simplifying a surd, we are breaking it out into two factors, one of which has to be the largest square number that's a factor of that number. So for root 80, the largest square number that's a factor is 16. Yes, 16, because root 16 times by root 5 gets us root 80. So square root of 16 is 4. 4 times root 5 is 4 root 5. Beautiful. Now we're going to simplify the square root of 2 and 2 ninths. Okay, so we need to do, let me just fix this, guys. I like when my writing is really clear, so no one gets confused here. So I need a smaller 2 here. So 2 and 2 ninths. There we go. So converting this mixed number to improper fraction, first of all, I get 9 times by 2, which is 18. 18 times by 2 here is 20. So this can be written as square root of 20 ninths. Please note that we could also break them apart since it's a division. So we could have root 20 over root 9. Then let's simplify that. So the largest square number, that's a factor of 20, is 4. So 4 times by root 5 is root 20. And then we can simplify square root of 9, which is 3. So the square root of 4 is equal to 2. So numerator is 2 root 5 over 3. Now that we've simplified root 80 and also root 2 and 2 ninths, now we can add them together. So root 80 is now 4 root 5, and we're adding that to 2 root 5 thirds. Remember, we cannot add fractions or subtract them if the denominators are not the same at all. So what we got to do now is put this one over 1. Remember, every whole number over 1 is a fraction. So common denominator would be 3. So I need to times this denominator by 3 and also the numerator by 3. So 4 times 3 is 12. So that's 12 root 5 thirds. So 3 times 1 is 3 plus 2 root 5 thirds. Now my denominator is the same. I can now add them together. So we add the coefficients of the roots. So 12 plus 2 is 14. And the common root is 5, and the common denominator is 3. Cannot be simplified any further as there is no common factor with 14 and 3. So the correct answer here, final answer, is 14 root 5 thirds. Correct way to say it, by the way. Beautiful. So now we're going to do our final question on surds, which asks us to rationalize and simplify. So let's underline that, simplify. And give your answer in the form a plus b root 5, where a and b are integers. So key point here to think about, what does the word rationalize mean? To rationalize means that we are removing the surd from our denominator. It is not appropriate then to say that a surd should be in a denominator of a fraction. So when we rationalize it, we are removing it. Now, to do that, especially when we have the form where we have two expressions here, root 5 and root 1, we have to do that using what we call a conjugate. Now, a conjugate basically takes the form of the difference of two squares, okay? Because when we multiply the difference of two squares, the b term always cancels out to 0. So Just another point of information. The question says we should give the answer in the form a plus b root 5. Just to note that this b here, this plus, may not always be a plus. It could be a minus, and that's because we could be adding a negative. Adding a negative is like multiplication, so this will still cancel out to a minus, because lots of time people work their questions out, didn't see a minus as the question, a plus as the question said, get the minus, gets the right answer, and then changes it. So hope that clarifies something there. Okay. So let's rewrite this now. Root 5 minus 7 divided by root 5 plus 1. So we're putting that in bracket, both of them. The conjugate of root 5 plus 1 is the difference of two squares would be another one, but a negative one. So we're going to do that at the top as well. So this will be root 5 minus 1. Close our bracket. Now we're going to expand the brackets, paying attention to our signs. So I've got root 5 times root 5. Remember, when I multiply two identical roots, then I'm going to only have the number. So root 5 times root 5 is just 5. Then root 5 times by minus 1 is minus root 5. Then minus 7 times root 5 is minus 7 root 5. And then minus 7 times minus 1 is positive 7. So you notice how I say it out. Make sure you say it out to yourself as well. Now we go for the denominator. Root 5 times root 5 is 5. Root 5 times by minus 1 is minus root 5. Then positive 1 times root 5 is positive root 5, and positive 1 times minus 1 is minus 1. So now we are going to simplify, okay? So we collect like terms. So positive 5 plus positive 7 is positive 12. Please make a note of that. Minus root 5, so this is like minus 1 root 5, minus 7 root 5 is minus 8 root 5. Dividing by simplifying the denominator, the negative root 5 and the positive root 5 cancels out to 0, hence why it's a difference of two squares when we expand it. So 5 take away 1 is 4. So I'm just going to rewrite it here. 12 minus 8 root 5 quarters. Now we can simplify this further because we have a common factor. So 4 goes into itself, 4 goes into 12, and also into minus 8. So let's go. 4 into itself goes once, 4 into 12 goes 3 times, and 4 into minus 8 here will be minus 2. So the final answer is 3 minus 2 root 5. So let's check now. In here, so very good, I told you that in the beginning. You can see here, instead of the plus, there is actually a minus here this time, but it is correct. So A then would be equal to 3 and B would be minus 2. There we go. Absolutely fantastic. So now we are moving on to standard form. Beautiful. Starting off, we are asked to solve x divided by 0.02 is equal to 3.1 times 10 to the power of 4. We need to give our answer in standard form for 2 marks. So we can see here, rewriting our question, x over 0.02, that's equal to 3.1 times 10 to the power of minus 4. So if I am to solve this, I need to do the opposite of dividing by 0.02. So I'm going to be multiplying this side by 0.02. So x would be equal to 3.1 times 10 to the power of minus 4. And I'm multiplying that by 0.02. We must be able to see here 0.02 is not in standard form. We need to put it in standard form. Remember, numbers in standard form can start at 1, but they cannot be double digits. So can't be 10, has to be lower than 10. so single digits. So I'm going to just rewrite 0.02 in standard form. To get it as a whole number now in the right form, 1, 2 spaces to the right, so that's 2 times 10 to the power of minus 2, since I moved 2 spaces to the right. So I'm going to rewrite this now. 3.1 times 10 to the power of minus 4 times by 2 times 10 to the power of minus 2. So I'm going to be collecting my like terms, so I need to multiply 3.1 times 2. So double 3.1 is 6.2. And then remember, in indices, when we are multiplying and the base is the same as in 10 and 10 here, we need to add our powers. Be careful. So this is going to be 10 to the power of minus 4, and minus 2 will give me minus 6. Be careful. So it's 10 to the power of minus 6. Guys, if you have to use a number line and start at minus 4, go 2 backwards to see that it's still negative and negative 6, do it. Do it. Do what you got to do. Okay, moving along to another standard form question. Here are 5 numbers. 47,000, 4.5 times 10 to the power of 4, 5 times 10 to the power of 3, 2.8 times 10 to the power of 5, and 125,000. Work out the difference. Lots of students mess up this one. Remember, difference means to subtract between the largest and the smallest numbers and give your answer in standard form. So, best thing to do here is to convert them. Okay, so I'm going to see what is, notice I work out everything. 4.5 times 10 to the power of 4 means that I am moving my place value, not the decimal point, my place value. So I'm going to move 4 places to the right. So 1, 2, 3, 4. I'm going to fill these with zeros now. So this is essentially 45,000. Finish with that one. This one, 5 times 10 to the power of 3 is the same as 5,000. So let's put this one here. 4, 5, 1, 2, 3. Notice I'm even counting my zeros. So this is just 5,000. Okay, now this one I'll do here. So 2.8 times by 10 to the power of 5. Again, I'm moving 5 spaces to the right. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so this one is 280,000. 1, 2, 3. Count your zeros, guys. Now we have them all in ordinary numbers. So we need to identify the largest one and also the smallest one. So the largest number is 280,000 and the smallest is 5,000. So essentially, I'm doing 280,000. Take away, make sure you line up properly, 0005. If you don't line up properly, you are going to get the answer wrong. So let's subtract now. 0, 0, 0. Got to take 1 from here, leaving 7. So 10 take away 5 is 5. I've got 7 in this column. I've got 2 here. So the answer is 275,000, but I've underlined a key fact here. The degree of accuracy has to be in standard form. So let's get this back to standard form now. So 1, 2, 3, 4, 5 spaces for it to be a single digit there. So 2.75 times 10 to the power of 5. Absolutely fantastic. Break it down for your 3 marks. Good to go. Now we're asked to work out another standard form where we're multiplying 2 brackets together, give our answer in standard form. Now, what we need to do here, work out 3 times 10 to the power of 5 multiplied by 6 times 10 to the power of 9. We need to give our answer again. If I was supposed to have marked your GCSE paper, I would love to see you underline on that paper the key points in the question. Do it. Mark up on that paper. If it's diagram, write on the diagrams. You've got to work for this mark. Okay, so in these questions, we need to collect our like terms. So 3 and 6 are whole numbers. So we need to do 3 times by 6 in one bracket. That's being multiplied by 10 to the power of 5 times by 10 to the power of 9. So So now I'm going to multiply 6 times by 3, which is 18. And laws of indices tell me to add my powers when I'm multiplying. So 10. 5 plus 9 is 14. But I need to check, is 18 in standard form? And the answer is no. Make sure you don't make this mistake. So I'm going to rewrite 18 in standard form. So it's going to be 1.8. So we're going to go one space times 10 to the power of 1 times by 10 to the power of 14. Now I will simplify. It's 1.8 times 10 to the power of 1 plus 14. That is 15. Absolutely brilliant. Now we're moving on to a division where the same principle applies. Collecting my like terms. So work out 3 times 10 to the power of 5 divided by 6 times 10 to the power of 9. Give your answer also in standard form. So collecting my like terms, remember this time I'm dividing. So 3 divided by 6 in one bracket times by, in the other bracket, 10 to the power of 5 divided by 10 to the power of 9. Beautiful. So lots of students, when they get here, they make silly mistakes by getting this answer for 2. Remember, small number divided by a large number. So 3 divided by 6 is a half, which is best to write as 0.5 times by, when we are dividing, we subtract the powers. So 5 take away 9 is minus 4. We're then going to rewrite. So 0.5 is not in standard form because the number cannot be less than 1. Remember this. So I'm going to write this, moving one space here. This will be 5 times 10 to the power of minus 1. We're combining that back with 10 to the power of minus 4. So I get 5 times, remember, adding the indices now, minus 1 and minus 4 gives me minus 5 again. If you got to use the number line, then you'd need to do that. But this is the moment you're fighting for that grade. And guess what? We are winning that fight. Beautiful. So we're going to move on now. Here we're asked here to do 2 to the power of 8 times 3 times 5 to the power of 2 is equal to 600. We're asked to work out the value of A, and you must show your working. Then we've got an indices at the bottom of that. So I want to find out what is A. The best thing to do here is to write 600 as a product of its prime factors. And then when I get them, I will see how many 2's I have, and then that will be my answer for A for the power. So we can go for 6 times 100. Remember, all of our numbers should essentially work out to be prime numbers. So I can break 6 out into 2 and 3, circle, circle. Then 100 can be written as 2 times by 50. Circle 2 is a prime number. Then 50 can be written as 2 times by 25, circle. Then 25 can be written as 5 times by 5. Beautiful. So let's write that all out now. I've got 1, 2, 3 2's. So that's 2 to the power of 3 multiplied by, I've got 1, 3, which is what I was given in the question. And I also have 5 times 5, so that's 5 squared. So now 600 is equal to that. I can see clearly my 2 to the power of 3 here would be equal to 2 to the power of A. So the bases are the same. So the bases are the same. So the powers are also the same. So A is equal to 3. Absolutely spot on. 3 marks, nice and easy. Product of prime factors, easy to get. Okay, so now we're going on to the question that says work out the value of 8 to the power of minus 2/3. Now, most of you can do where you have a positive power. Now, I will cancel the thought right now that makes you think that a negative power have anything at all to do with negative numbers. It does not. So it means you have a fraction. Okay, so let me clarify that quickly. So just like how we can have on the place value chart, ones column, we can have tens, then hundreds. We can say 10 to the power of 0, 10 to the power of 1, 100 is 10 squared. We also have the decimal side as well. So here is where we have our tenths with TH, which is 1/10. We write that as 10 to the minus 1. 100 is 10 to the minus 2 because it's 100. When we are doing indices, we are talking about the fractional side as well. So it's going to be rewritten as 1 over 8 to the power of 2/3. You can work out 8 to the power of 2/3 and then put 1 over that answer, but I want you to get the concept here. So in the laws of indices, the denominator tells us our root. Denominator is our root, and the numerator tells us our power. So what this is telling us to do is the cube root, the third root of 8, and when we get our answer, we should square it. So we have 1 here. Don't put 2 equal sign in your equation, not mathematically correct. Use an arrow. So the square root of 8 is 2. And when I square that using my power, I get 2 times 2, which is 4. So my answer then is 1/4. See, so easy. Just talk yourself through. It's that mathematical dialogue that gets you to the final answer. So talk to yourself, guys. Talk to yourself. Okay, so we are moving along. Now we are going to do this question here that says write 16 times 8 to the power of x as a power of 2 in terms of x. As a power of 2, I've got to clarify something here. Now, when people hear about power of 2, they're thinking that 2 should be the power, but no, it means you should write 2 to the power of something, okay? So first thing we need to do here is to write 16 as a power of 2. So 16 is equal to 2 to the power of 4. So now that's in base 2. We're going to write 8 to the power of 2x as a power of 2 as well. So 8 in itself, 8 is 2 to the power of 3. 2 times 2 is 4. 4 times 2 is 8. So this is now 8. But 8 was also written to the power of 2x. So to simplify 8 to the power of 2x, remember, laws of indices says when we have a power to a power, we times them. So 3 times 2x is 6x. Now that we've got them in the same, we can now write 2 to the power of 4, that's now 16, and 8 is 2 to the power of 6x. Remember, guys, when the base is the same, we can keep the base and add the powers. So here we will have 4 plus 6x. Cannot be simplified any further because one is a number and one is an expression. Absolutely brilliant. So, guys, we are going to move on to our next question, but put in the comment section how you feel about this walkthrough. Come on, I can feel the positive energy coming to you through the screen. So let me know what your thoughts are. Okay, so now in this question, we're told that n is a number. As a product of prime factors in index form, n is equal to 2 times by 3 to the power of 4 times y to the power of 13. Of 3. So we are asked to work out 3n squared as a product of its prime factors in index form. So we need 3n squared, which is essentially 3 times by n squared. So 3 times by n is equal to, let's put a bracket, 2 times 3 to the power of 4 times by y to the power of 3 as well, and that is being squared. So now we are going to apply the laws of indices for power to power rule. So it's going to be 3 times by, remember, when we have a power to power, we multiply the indices. So we're going to put a 1 here to remember that there is a power of 1 here. So it's going to be 2 to the power of 1 times 2, which is 2, times by 3 to the power of 4 times 2, which is 8, times by y to the power of 3 times 2, which is 6. Now we realize we have 2 sets of 3's here, so we need to simplify. So we're going to start with our 2 squared first, times by, we got a power of 1 here for the first 3, plus the 8, which is 3 to the power of 9, and then times by y to the power of 6. So 3n squared, therefore, is equal to 2 to the power of 2, 3 to the power of 9, and y to the power of 6. Well done. Okay, so now we go back to another question, where in this one we are asked to do the square root of 6 squared plus 8 squared is equal to the cube root of 125a cubed. We are to work out the value of a for 4 marks. So let's go, guys. So let's rewrite this. Root 6 squared plus 8 squared is equal to cube root of 125a cubed. So let's simplify both sides. Square root, square of 6, 6 times 6 is 36, plus 8 times 8 is 64, a common one, we should remember. This is now going to be square root of 36 plus 64 is 100, so all of this side simplifies to 10. So now let's simplify the other side. So the cube root of 125 is 5, since 5 times 5 times 5 is 125. The cube root of a cube is just a. So essentially, we are doing 10 equal to 5a. We then need to divide by 5 on both sides. We get that 2 is equal to a, therefore a is equal to 2. So sometimes these things look complex, guys, but it's the way it's broken down to you. Make me know if it's very clear for you. Okay, so now we go to another question. So this time we are asked to solve 4 to the power of x is equal to 8 to the power of 2 root 3 for 3 marks. Solve means to get a value for x. So let's go. First of all, I know, remember, we can only equalize our bases if they are the same. So I have to rewrite 4 and 8 in a common base, and that common base is 2. Since 4 is 2 squared and 8 is equal to 2 cubed. So let's write that out. So 4 to the power of x can be written as, for 4, we will write it as 2 squared. So this is 4 in bracket, but that was raised to x. Power to power tells us we need to times the indices. So this is 2 times x, which is 2x. So for all of this side, we've gotten that. Let's simplify the next bit. So 8 to the power of 2/3. Remember, this means that we are finding the cube root. So that's the root, and this is the power. We've experienced this in the question before. So we're doing the cube root of 8, and we should square the answer. So the cube root of 8 is 2, and 2 squared now is equal to 4. So now that we've simplified them, now we need to make them equal. But we don't need to write this 4 out because we are making them in root 2, sorry. So it's going to be 2 to the power of 2x equal to 2 squared. Now, the laws of indices say when the base is the same, the powers are equal. So therefore, 2x is equal to 2. Dividing by 2 on both sides, I get that x is equal to 1. Absolutely brilliant. So again, we make sure that we break the question down a step at a time. Looks difficult, but logical, clear thoughts make it accessible to all of you. Next question asks us to simplify the square root of 3 to the power of 0 times by bracket 3 to the power of 1 plus 3 to the power of 2, give your answer in the form a root 3. So let's go for simplification. We know what BIDMAS tells us to do. BIDMAS tells us that we're solving our bracket first. So I'm going to keep my 3 to the power of 0, work my bracket out. 3 to the power of 1 is still 3, plus 3 squared is 9. Adding my bracket now, I will get 12 for 3 add 9. We know that any number raised to the power of 0 is 1. So simplifying this, 12 times 1 is 12, but we need it in a root form. So remember, we need the largest square number, that's a factor of 12, which is 4. So root 12 can be written as root 4 times root 3. So root 4 is equal to 2, and 2 times root 3 is 2 root 3. Now we've written it in the form a root 3, so therefore a is equal to 3. That's a number in the root, but on your answer line, you will put 2 root 3. Absolutely brilliant. So now we are going to do another question. So we're going to do 2 more indices questions, and then we are finished with indices altogether. So here we're asked to write down 49 to the power of m to the power of 2/5 as a power of 7 in terms of m. By now, we recognize that our answer is going to end with 7 to the power of something. So again, we're going to write 49 to the power of m as a power of 7. So 49 is written as 7 squared. That's 49, but that was also raised to the power of m. So 49, that will now be 7 to the power of 2m. Now, all of that is being multiplied, so 7 to the power of 2m is being multiplied by 2.5. Remember, we are multiplying them together, so 2.5 times by 2, doubling 2.5 is 5. So the answer is 7 to the power of 5, and we also have m, so the answer is 7 to the power of 5m. Final search question now. Indices, work out the cube root of 8 times by 5 to the power of -2. Key point, give your answer as a decimal. So let's go. Cube root of 8 is equal to 2, since 2 times 2 times 2 make 8. And 5 to the power of -2, remember, minus means fraction, so 1 over 5 squared. 5 squared is 25, so it's 1 over 25. So essentially, we are doing 2 times by 1 over 25. So put that over 1. 2 times 1 is 2, and 1 times 25 is 25. Remember, they've told us to give it as a decimal. Easiest way to do this is to get this 25 to 100 by multiplying it by 4, numerator by 4. 4 times 2 is 8. 25 times 4 is 100. Now I can convert this by going 2 spaces backwards. So that is decimal here, 0 here, there. So it's 0.08 as a decimal. See, looks complex, not complex at all, step by step. Absolutely brilliant. Guys, I'm so proud of you. I am so proud of you. And you're going to be proud of yourself in August when the results are out. So now we go to the famous circle theorems. Now, guys, if you know nothing about circle theorems, you forget about it. I've done a series, 3 separate lessons on circle theorems. You can find them here. This is the 3 videos here. Circle theorems 1, circle theorems 2, and circle theorems proofs. So I'm going to do 2 of these questions, 1 proof, and then you can find other ones. Make sure you watch the proofs, because if those come at the back for 5 marks, you should be able to. I've done the basic ones that usually come up. Make sure you watch those as well. So here we go. A, B, and C are points on the circle, center O. Key point here, center O. So let's highlight that. Work out the size of angle CAB. So that's a cab. That's what we're driving in to our grade 7 to 9. Okay, so CAB. So let's identify that angle straight away on the diagram. Give a reason for your answer. Now, as an examiner, I will say to you, always write a reason down, because sometimes within the mark scheme, there is a hidden mark for the reason. Always give the reason, even if the question doesn't say it. Can't say I didn't tell you. Okay, so to unlock this circle theorems question, It relies on our ability to remember the theorem that says angles in a semicircle. So notice the diameter here forms a semicircle. So when the angles meet off the end of the diameter, they form 90 degrees. So this angle here is 90. You're going to put here that angle ACB. ACB is equal to 90. Angles in a semicircle equal 90 degrees. So now I know angles in a triangle add to 180. So therefore, if this is 90, then let's call this x. This angle here plus 79 should also be equal to 90. So I can just write a simple equation. X plus 79 is equal to 90. Take away 79, take away 79. Do not take it for granted, but do your column method though it looks simple. So 9, 8 left. 10 take away 9 is 1. 8 take away 7 is 1. So the answer is that x is 11 degrees. Okay, and then your further reason is that angles in a triangle, okay, add to 180. So you can write that down. Make sure you write that down in your exam as well. Okay, so therefore, I need to end intelligently. They've asked me to find CAB. So I'm going to tell my examiner CAB is equal to 11. Don't just do calculation and leave it. Speak to the examiner like they are in front of you. This is where we unlock full potential of the marks that we have, especially for heavy tariff questions. So, but this one was 2 marks, but we work for it. Now I go to the full marker, which is of a more heavier tariff. So A, B, C, D are points on the circle with center O. Work out the size of angle ABC straight away. I'm going to highlight that ABC. This is what I'm after. So give reasons for your answer. So the first thing I notice here is that the circle theorem that applies here is that angle at the center is twice the angle at the circumference. So angle DOC, DOC is equal to 68 times by 2. Angle at the center, just going to put this at for now. You don't do it, write the word at out. Angle at the center is twice angle at circumference. Okay, so that means if we multiply this, 2 times 8 is 16. 2 times 6 is 12 plus the 1 is 13. So I know that this angle here, so I want you to write on your diagram. Guys, we mark your diagrams, write on them and close your gaps. So now I know this. I can use that to find these two angles. This is a radius from O to D. O to C is also a radius, so that means this is an isosceles triangle. So this is the circle theorem that says 2 radii, plural of radius is radii. So 2 radii, next reason, creates an isosceles triangle. 2 radii creates an isosceles triangle. Therefore, let's call this y. I can find this angle here because I need it to add to that one to find this using angles in a cyclic quadrilateral add to 180. So I'm going to find angle y. Y would then be equal to 180, take away 136 divided by 2. So 180 take away 136. You would have set this up as column method, and that answer is 44. So now I need to divide this by 2, which is equal to 22. So I'm going to put that on my diagram here or make an arrow. This is 22 there. Okay. So now I've got that. I know that angle ADC, so let's write that, ADC is equal to 45 plus 22, and that's equal to 5 and 2 is 7, and 4 and 2 is 6. Beautiful. So now I have a cyclic quadrilateral. A cyclic quadrilateral is when you have a 4-sided shape where all corners, all corners of the shape touch the circle. Guys, if all the corners of the quadrilateral doesn't touch the circle, it is not a cyclic quadrilateral at all. So this one is, so we know that the angle here, which we got for 67, plus this one, the opposite angles in a cyclic quadrilateral add to 180. So the angle we are after is ABC, will be equal to 180, take away 67, and you will write that and write the reason. So subtracting them, that answer is 113. And then you're going to now say angle in a cyclic, C-Y-L-I-C, quadrilateral, I just put quad, add to 180. Brilliant. 4 marks. Talk yourself through, write your reasons. You have got 4 marks in the bag. Beautiful. So now we go to the last circle theorems question, which is a circle theorems proof. 4 marks. A, B, and C are points on the circumference of a circle with center O. A or B is the diameter of the circle. As we say, we don't give loose information. This is critical. So that's why we've told you that. Prove that angle ACB is equal to 90. So we're proving that this angle here is 90 degrees, which is the theorem we just looked at in the first circle theorem question. We looked at the fact that angle in a semicircle is equal to 90. Now they've asked us to prove that this is true. When we're asked to do algebraic proofs in circle theorems, we must do it in algebraic proof. So the way to do this question is from the center of the circle here, we are going to draw a radius to create 2 triangles. Now, this is a radius, which means this is an isosceles triangle. This is a radius, OC is a radius, OB is a radius. This is another isosceles triangle as well. So in the first isosceles triangle, I'm going to call this X. And if they are the same, this angle also here will be X. But I'm going to use another letter Y here, and the other angle will be Y. So now I need to find the missing angle here. So angles in a triangle add to 180. So this angle at the center here will be 180 minus 2x. The other angle here then will be 180 minus 2y, because I have to subtract these 2y from 180. Okay, now I know that the angles in a triangle should add to 180. So let's go. So we've got those two. So let's write it out. So I know that these two are on a straight line. So angles on a straight line add to 180. So let's go. 180 minus 2x plus 180. This was supposed to be 2y here, guys. 180 minus, hold on, 180 minus, my mouse is messing with me, guys, but I am determined. So 180 minus 2y should be equal to 180. So remember, this is one angle on the straight line. This is the other angle. Angles on a straight line add to 180. So 180 minus 2x plus 180 minus 2y should equal to 180. So now let's collect our like term and simplify. So 180 plus 180 is 360. Then we will have minus 2x and minus 2y equal 180. So remember, we want to collect our like terms. So we're going to have 360. Bringing 180 here will be minus 180. Taking this over, we will get positive 2y. So that minus will become plus, and positive 2x. So beautiful. So subtracting this here, guys, I get 180. So 180 is equal to 2x plus 2y. Now, if I look at the top here, I got x plus y. So let's divide this by 2 and see what x plus y is equal to. So dividing by 2, dividing by 2, dividing by 2, because I want to see if x plus y here will be equal to 90. So 180 divided by 2 is 90. Then 2x divided by 2 is x. and then 2y divided by 2 is y. So guys, we have proven that the angle at C, which is x plus y, is equal to 90. That means for sure, so we're going to say, therefore, the angle ACB is 90 degrees. See, therefore, so it's a ABC are points on the circumference, prove that ABC is 90, so ABC is equal to 90 degrees. Beautiful. So what we need to do, again, watch this over. This is a common one that comes. We could also be asked to prove the angle at the center is twice the one at the circumference, and so on. But as I said, make sure you watch that video I have just spoken about. Okay. So now we are going to do some matching up of graphs. We are getting there, guys. We're getting there, a little bit of everything. So match each expression on the left with the equivalent one on the right for 3 marks. One has been done for you. So y is directly proportional to the square of x. So to x squared. So y is directly proportional to x is the first one we need to match. Now, remember, we always have a straight line for direct proportion. It's always a straight line starting from 0. So we check straight line starting from 0 is this one. I've just pre-put the markers in there. Next one we want to have is inverse proportion. So y is inversely proportional to x. This means that when x has increased, y is decreasing, and so on. So therefore, our graph will look like this one. Next one, we're asked to do y is directly proportional to x squared. I guess you guessed it. It will look somewhat like we are leaning towards a quadratic kind of a curve. Okay, and then finally, we have y is directly proportional to the square root. And clearly, it's going to be that one. Beautiful. So most of the times you get the same graphs. Maybe they will be labeled in a different order, but you need to know what they look like. Absolutely fantastic. Now we go to direct proportion. So we're told that y is directly proportional to x. When y is equal to 60, x is equal to 4. Work out the equation connecting y and x. So first step in direct proportion, we write y is symbol for direct proportion is this symbol, directly proportional to x, which means that y will always be equal to a constant k. This is always fixed constant multiplied by x. So y will always be equal to kx. So the first thing to do here, guys, is to work out what is k by substituting the values for y and x here. So y is 60 and k times by x, and x is 4. So 4 times k is 4k, and that's equal to 60. Dividing by 4 on both sides, we get 60 divided by 4 is 15, equal to k. So now that we know the value of a, we can write the equation. So we use this one here, but substitute k. So this will be y equal to, instead of k, I'm putting 15 and x. So this is my equation that links x and y. Y will always be equal to 15 times by x. So here is a connecting question. But before I do it, remember, even if the question doesn't ask you for the equation that links the two variables, we require you to do it. Do it first. So part B, so let's just put A here. So B then says, work out the value of y when x is 20. So because I know my formula is y equal 15 times of x, I'm substituting x for 20. So y is equal to 15 times by x, which is 20. 15 times 2 is 30. And I've got a 0 at the end. So y will then be 300. I'm so proud of you. I am so proud of you. Absolutely fantastic. Okay, so now we are moving on to an inverse proportion. Same principle apply, but now it's inverse. So if we multiplied by k, so if we multiply k by x, in the other one for inverse, we're obviously going to do division, okay? So J is inversely proportional to the square root of F. When J is 12, F is 9. So let's go. J is inversely proportion, so it's going to be that, but this time it's going to be 1 over K. And then we are going to be finding what K is just the same. So J is inversely proportional to the root of F. We underline that. J is 12 when F is 9. Work out an equation connecting J and F. So J is inversely proportional to, so for inverse, we do 1 over root F, because that's inverse. So therefore, J will always be equal to K divided by root F. So we're going to substitute J in. J is 12. That's equal to K over root F, and F is 9. So the square root of 9 is 3. So we have 12 equal to K over 3. So to find K, we will do 12 times by 3. So K therefore is equal to 12 3s 36. So the equation connecting them using this one, we get J is always going to be equal to, we're replacing K with 36 now that we know that it is, equal to 36 over root F. So we're finished with part A. Part B asks us to work out J when F is 4. So using the equation J, so this is part B, J is equal to 36 over root F. And root F is, so we are using 4. So therefore, J will be equal to 36 divided by the square root of 4. Square root of 4 is 2. So J is equal to 36 over 2. That's equal to half of 36 is 18. So that's our final answer. But it could also have been minus, because this, we could get a negative value also from root 4. Two negatives timed together give a positive. So this answer could either be, root 4 could either be plus or minus 2. If we were using the minus, then it would have been 36 divided by minus 2, which would have been minus 18. But we can keep that one because it just says value. But if the question said values, that's what you would have done. Okay, for the next question now, we go to transformation graphs. So we're given that the graph of y equal f of x and y equal g of x are shown on the grid below. So part A asks us to draw the graph of y equal f of x plus 1 onto the grid. So this one. So this means that the graph is going to, so whenever we have a change that happens outside of a bracket, we mean that we are either the y is affected, so we are moving either up or down. If the change was inside the bracket, it will be the x coordinate, so it would be translating to left or right, depending on what we have. So this means that we should move this graph one place up. So we choose important points that we can identify. So this point will go one place up. This point here will go one place up. And this point will go one place up. Then we swing a nice smooth curve to go through it, which I have pre-put in to make it neater. So you can see all points one place up. So that's the transformation of that graph. Now we are asked to do g of x minus 2. So I bet you figure out changes outside the bracket. Each point is going to go 2 places down. So from here, 1, 2, new coordinate here. This one, 1, 2, new coordinate here. This one, 1, 2, new coordinate here. Next side, 1, 2, and then 1, 2. Then we will connect them using our ruler, pre-drawn that in as well. So that's a little bit off for my pre-drawn one, but you can see this is 1, 2 down, 1, 2 down, and all of the points are 1, 2 down. So my animation is a little bit off, but you can see they are 2 units down all the points. That's it. So sometimes when you see these, you get panicking. No need to do that. Okay, so quick examiner's tip here. If you're given a graph and its transformed version, you must say the type of reflection or translation it is and the direction and the amount. So for example, if you describe the transformation from y equal f of x to y equal f of x minus 3, this means that the graph is going to move. It's a translation. It's inside the bracket, so it's going to move 3 spaces minus 3, not what you expect. When you have a minus, you are going to the left in transformation graph. And if you have a plus, you're going to the right. So remember this. Okay, so minus means that we're going 3 units to the right. Okay, so now for this question, the graph of y equals 3x squared plus 2x minus 5 is reflected in the x-axis. So if you think about this, if I have a point here, a square there, and I'm reflecting in the x-axis, I expect my coordinates to be negative in the reflection for y here. So that means we are told that it's reflected, the reflected graph has equation y equal f of x, work out f of x. So because it's going to be reflected in the x-axis, it means that we will have minus f of x. So all we need to do, work out your answer in the form ax squared plus bx plus c, where a, b, and c are integers. So all we simply need to do is to multiply the value we already have by minus 1, because the coordinates are going to become the opposite of what they are. So for this question is 3x squared plus 2x minus 5. It's reflected in the x-axis. I need to just reverse them. So minus times by 3x squared is minus 3x squared. Minus times by 2x is minus 2x. And minus times minus here. So basically the coordinates or the numbers are just reversed to their opposite. Absolutely brilliant. Okay, so we are now going to move on. So let's identify what A and B are. So A is minus 3. They didn't tell us to do it, but it just say where A and B. So A is minus 3, B is minus 2, and C is 5. You can write that, let your examiner know that you know what you're doing. So in this question, we're told that the ratio of A to B is 1/7 to 3/5. What is A as a fraction of B? So circle your answer. So guys, this was supposed to be a multiple choice, but I didn't bother to do that and I forgot to change it. So I wanted you to work it out. So forget about the circle your answer part of it. So A to B as a fraction. So A as a fraction of B. Now remember, if A is a fraction of B, then B is the denominator of the fraction. So basically, we're doing 1/7 divided by 3/5. So let's just rewrite that. 1/7 divided by 3/5. So applies the laws of dividing fractions. Keep, change, flip. Remember, KCF. So 1 times 5 is 5, and 7 times 3 is 21. So it's 5/21. Yes, it's that simple. It is that simple. So now we're told in the next question, the ratio of girls to boys in a class is x plus 3 to x squared plus 3x. Write the fraction of girls in the class as an algebraic fraction in its simplest form. So girls to boys, so girls is this part of the fraction and boys is this part. So remember, it asks us to write the fraction of girls in the class. So we need the total. So remember, just like ordinary, if we had numbers, we will add the ratio parts together. So it's x plus 3. Let's write total is x plus 3 plus x squared plus 3x. So we're going to collect our like terms. So we have x squared as the highest power plus 3x plus x is 4x. And then we have plus 3. So this is our denominator. So therefore, we are writing the girls, which is x plus 3 as a fraction of the total, which is x squared plus 4x plus 3. I hope you learned from part 1 in algebraic fractions that we have to factorize the denominator here. So this will be equal to x plus 3 for numerator. We know we're going to have an x plus 3 in the denominator as well. So we need 2 factors of 3 adds the 4, that's 1 and 3. So 1 times 3 is 3, but 1 plus 3 is 4. So 2 brackets, one bracket will be x plus 3, and the other bracket will be x plus 1. Check. 3 times 1 is 3, but 3 plus 1 is 4. Now we can simplify. So x plus 3 divided into itself goes once and cancels out with that goes once. So in the numerator, we have 1 over 1 times anything is the same value. So x plus 1, and that is in its simplest form. So now we are going to go for this shape that's on an isometric grid. So a solid shape is drawn on an isometric grid. We're given that solid. We can see here we've got an arrow pointing to the face of it. We are asked to, on the centimeter grid, draw the elevation of the shape from A. So from A, we are looking dead onto the shape. We will be seeing this face if we stand at A, but don't forget we're also seeing that one. So we need to count the grid. It's a centimeter grid. So across we have 1, 2, and the other one here will be 1. So it's 1, 2 across. I think I've pre-drawn this in. So let me just write the dimensions and then put the diagram in. So erasing back this line. So let's just write the dimensions we should have, and then I will just put, so 1, 2, 3 across. So this is 1, 2, and that one, 3 across. And the height from top to bottom for both of them is 1, 2. So we need to have 3 across, 1, 2. So we put that in. So 2 down. So that's what it looks like. Now, some people would have done the 2 first for this face and then done 1 after. We don't need to do that. So the answer will be that shape that there, which is a rectangle. It's a 3 by 2. And then we need to do, for this bit, we now need to do part B. On the centimeter grid, draw a plan of the shape. So when we talk about a plan, we're talking about what you see if you should be above the shape and look down. Clearly here, we can see that we can see a L shape. Doesn't matter where on the grid you draw it, but the dimensions are important. So we can see across we got 1, 2, 3. So we need 3 squares across. Going down to the side is 1, 2, 3 as well. Then we have 1 across here, 1, 2 down, 2 across, and 1, 2, 3, 4, 5. So let's just put, we need 5 for that side. We've done 3 for that side. This part will be 3 as well. This bit will be 1 across there. This is going to be 2, and this is going to also be 2. So our L shape should take that form. I've put my 3 in already. The side length is 5. So 1, 2, 3, 4, 5 squares. Then we've got 3 down, 1 across, 2 down, and 2 across. Now we've accurately drawn that L shape, which is the plan view, bird's view. Some people call it bird's eye, what the bird looks down and see. Beautiful. So we have 2 questions left to go, and then we are going to wrap up this session, guys. Look at you finishing the whole walkthrough. So shape A and B are shown on the grid below. We got A here, we got B there. So we are asked to translate shape A by vector 5 minus 2. It means that each part of the shape, we should move 5 across, 2 down, 5 across, 2 down, and so on. So let's take 1 point at a time. We will label the image C after we've done it. So if taking the first point here, we're moving 1, 2, 3, 4, 5 across, 1, 2 down. First point there. So for the next point, let's take another one. So for this one, we would move 1, 2, 3, 4, 5 across, 1, 2 down. Now, truth be told, my mouse is not behaving itself, guys. So, truth be told, once we get these 2, we can see the next point will also be here. Then we have 1 down, so we will need 1 point here, 1 down, 1 point there. So once we get 2 in, we can just draw the rest. So now you need to use your ruler. Didn't pre-draw this one in, so I'm just going to freestyle, but you need to use your ruler and your pencil. They've told us to call it C, so we've done with that one, 2 marks. Now we're asked to translate b by the vector minus 3, 0. So for y, we can see we won't move. So we're just moving 3 across. Remember, follow the sign. So first point, 1, 2, 3 across. Second point, 1, 2, 3 across. No movement on y. So let's do it again. 1, 2, 3 across. And then the next point, 1, 2, 3 across. So now we need to join them all together. With our ruler, we were told to call that D. Now I want to use this point to say a follow-up question to this could ask you, what is the coordinate of the point that is invariant? Invariant. So invariant means the point that didn't change after it is reflected. Now, in this case, all the points have changed, but let's say this was a reflection down here and you reflect this shape. Any point that didn't move from its original place, for example, if it was on the line, then that point would be an invariant point. So after you do a transformation and you have a point that did not change from its original position, it's still in the same place, that is called an invariant point. Make sure you know that that question comes up a lot. And so guys, here we are onto our final question in this review. I'm so proud of you. So we're asked to enlarge a by scale factor minus 2. Very important there. Center is 5, 4. So we're going to plot 5, 4. And 5, 4 is here, so we plot that point. Now, whenever we are enlarging by a negative scale factor, this means that the image is going to come on the opposite side of the center. That's what it means, negative. So we are going to move 5, we are at 5, 4, we are enlarging by scale factor minus 2. The shape will be 2 times bigger, but it will be on the opposite side of the center. So we need to first of all count how did we get from the center to the first point here. So let's just call the first point here A. So to get from the center to A, we had to go 1, 2 across, 1 down. It means we don't need to go. So we went 2 left, 1 down. We're going to need to go 4 right, 2 up. So from center, 1, 2, 3, 4, 1, 2 up. So we're doubling the distance, but in the reverse. So to get this point here, this one is nice and neat because we're just translating across. 1, 2, 3, 4. Remember, we're doubling. We need to go 8 the other direction. 1, 2, 3, 4, 5, 6, 7, 8, dead onto here. For the next one, for this one, you could just fill it in because clearly we know that this is 1, 2, 3 across. That means this one should be 6 then. So 1, 2, 3, 4, 5, 6. Okay, so we now need to just join our line. And remember, you're doing that with a ruler. I think I had pre-put this in as well, guys. So I'll just put that there. So if you were given this, so that's your enlarged shape on the opposite side of the center. Now, if you were given A, so let's just call the new shape B. Let's say you were given these two shapes, and this was the question, and they'd ask you, what is the single transformation that maps A to B? You will then count 1, 2, 3 for this side, and then this will be 1, 2, 3, 4, 5, 6. So you can see that it is doubled, but you need to say that it is an enlargement. The scale factor is doubled, but it's going to be minus because clearly it's on the opposite side of the center. So you would have said scale factor minus 2. And then you have to say the center. Now, in order to find what the center would be, you would draw lines, straight lines to match the corresponding side. So I've put that in. So you would connect the matching sides together. the tips together, the tips together. So where they intersect, you would now be able to find the center. So it's 5, center, 5, 4. And that's how you would have described it. Okay, because clearly you could get the question where they gave you the shape, its enlargement, and ask you to describe it instead. So when you're describing an enlargement, you have to say, 1, it's an enlargement. You also have to say what the scale factor of enlargement is. You have to also say what the center is. Okay, make sure that you do that. Beautiful. So guys, here we are. We have completed a complete revision for paper 1. And I am confident, because I see some of you already have put in the comment section how useful these videos have been. And I'm so proud of you. I'm thankful that you're a part of my community. And guys, for those of you who got to the end of this paper, and if you haven't seen the first paper, make sure that you find the first paper. Very useful questions as well. So, all right, you made it through that. You are actually now in a solid place for your paper 1. But be honest with yourself. So when you're using the revision checklist, if it is that you are not so confident on some topics, you need to go back through those as well. Tick off the ones that you are comfortable with, guys. And remember, we speak positively over ourselves all the time. I can do all things. I can do all things. Don't say, oh, I didn't think I'm going to fail. We are going to write in the atmosphere what we want to happen. So you're going to look yourself in that mirror. You're going to tell yourself, I am going to be successful in my math exam. And let's create that positive energy in the atmosphere. Thank you so much, guys, for being a part of this walkthrough. And I wish you all the very best in your paper 1 when it comes.